All right, this is lesson 1.2.2. Can I predict the outputs? The essential question for today is when is, write this down, when is a function actually a function? That means you can't always call a function a function. Sometimes a function is not a function. Here we go. It says, you have studied relationships between inputs and outputs. But what happens when the relationship gives you unpredictable results? Underline unpredictable results. If you have unpredictable results, that means it might not even actually be a function. That is, what happens when you cannot predict the output for a given input? Today you'll study the situation and will be introduced to the quality that makes a relationship a function. Have you ever pressed a button on a vending machine, yes or no? When's the last time you actually wanted to get some M&Ms and you, or maybe some chips or some gum from a vending machine? You press the number 143, which means I love you. You press 143 because that says it's going to give you gum or chips, but actually it gives you nothing. Did that ever happen to anybody? Where you press a button and nothing actually comes out? You're like, oh my goodness, it's stuck. Or what if you press the button 143 to get you some Twix, but some orange Fanta comes out? Wouldn't that suck? Can you understand that that means it's not a function? If I press a button for Twix and something else comes out, then it's not a function. If you can understand that, you understand a very major piece of this lesson. Okay? Let's read. The soda machine. The soda machine at your school offers several types of soda. There are 2 buttons for your favorite drink. What are they? Blast. And the other drinks are Slurp, Lemon Twister, and Diet Slurp. They each have 1 button. Describe the input and outputs of the soda machine. What this means is, look, if you can kind of see it from the diagram here, we have Blast, we have Slurp, we have Lemon Twister, and we have Diet Slurp. There are 2 buttons for Blast. As you can see, there's 2 buttons for Blast. 2 buttons. And then there's another button for the other 3. Okay. Is it okay to have 2 buttons for your favorite drink?
Yes.
Have you ever seen a vending machine that you press Twix and you get Twix? Coke, because Coke is more popular. Is that still a function machine? Does it still work? Even though there's many different options to press? It's still a function because you're hoping if you press the Coke button, what comes out? Coke. But if you press the Coke button, or this Coke button, and something else comes out, is that a working machine? No, that's not a function. Quite literally, it's the same here, okay? So describe the input and output of this soda machine. We're going to leave that blank because I think we understand it by the picture. So say, see picture. See picture. All right, next question. While buying a soda, Miss Whitney pushes the button for lemon twist. A can of lemon twister. Later, she went back to the same machine. You hearing this? Later, she went back to the same machine, again pushed the lemon twister button, but this time she got a can of Blast. Is that machine functioning consistently? Why or why not? Can somebody please share that? You're pressing the button, you're hoping to get lemon twister, but a Blast comes out. Is that a functioning machine? Yes or no, and why?
No, because if she pressed the lemon twister button, she should have gotten the can of lemon twister.
So we'll say,
If she got the Blast, then that is no longer a
so LP, lemon twister, should be giving her what? LT. It should be lemon twister. But it gives her something else. So that's not a functioning machine. Oh, thank you. There it is. All right, next one. When Brandy pushed the top button for blast, she received a can of blast. Right up there. Her friend Miguel decided to be different and pushed the second button for blast. Right there. He too received a can of blast. Each of them asked 5 friends to push the 2 buttons, the 2 blast buttons, and they all got blast. A nice juicy can of blast. Is the machine functioning consistently? Why or why not? What do y'all think? Raise your hand. Mom.
It is working consistently because they're getting one blast can from the same buttons that say blast.
So let's just write down they're getting blast from different buttons that say what?
Blast.
Say blast. Are you understanding this lesson? It's pretty straightforward so far. When we flip the page to the next questions, it does get a little bit more difficult. So let's say, when Lautfi pushed the button for slurp, he received a can of lemon twister. Later, Taisha also pushed the slurp button and received a can of lemon twister. Still later, Taisha noticed that everyone else who pushed the slurp button received a lemon twister. Is the machine functioning consistently? Here's the thing, you're pressing different buttons and everything's getting you lemon twister. How would you describe that answer? Yes or no, why or why not?
I would not call it functioning correctly, but it would be consistent.
So you'd say not correctly? Not correctly functioning. But, just a little note, it is consistent. That's good. That's a good answer. Could you use a little bit of a tape and like maybe a sticky note and just change it and say, oh, this one's giving you lemon twister. This one's giving you lemon twister as well. The thing is, everything's giving you lemon twister. Maybe you just need a piece of tape to change it. So, not correctly functioning, but it is consistent. Is it a function machine though? Is it a functioning machine? No. So you could say no. Is the machine consistent? Yeah, but it's not a good functioning machine. All right, next page, flip it over. All right, these are the types of questions that you're going to get on your tests and quizzes. In a relationship like a soda machine, we want the output to be consistent. We want the what to be consistent? Want the output to be consistent and predictable. When it is, we say that the machine is functioning properly. Examine these tables and graphs that show different inputs and their outputs. Decide if the relationship should be described as a machine that is functioning. If it's a machine that's functioning, we just call that a function. So, what do you think about this first one? We got different buttons that lead us to different things. You press 1, you get sticks. You press 1, you get sticks. 2 gives you M&Ms. 4 gives you M&Ns. 2 gives you duds. And 3 gives you duds. Is that a function?
No.
Why not?
Because the button 2 gives M&Ms.
Very good. 2 is giving us 2 different things. That is not okay. 2 is telling us you're getting 2 different things. The button number 2 needs to give you only what? One thing. So you'd say for this one, not a function. Good. All right, next one. 7 gives you -6. -2 gives you -3. 0 gives you 4. 4 gives you 2. 9 gives you 10. -3 gives you -3. And 6 gives you 0. Here's the trick. Do you see any repeating numbers here?
No.
Where? Which one? Which one repeats on the only on the inputs though? Because those are the different buttons we can press. Any of those repeat? So it's a function. That means all these buttons are unique. Every button gives us one unique output. Is it okay that they give us the same thing as the output?
Yes.
Yeah. Because one button can give you Twix. Another button can give you Twix. Is that okay? Yeah, it's a function. All right, next one. Do we have any repeating inputs? Look at these inputs. Which one repeats?
2, 9.
Okay, the 2 and the 2. The 2 gives you a 9 and the 2 gives you a -8. Is that okay? So right here, say not a function. So there's a trick to this, right? All you got to see is there any repeating input? Do I have a repeat input for the first problem here? Letter or number 1. Repeating inputs giving me 2 different things, not a function. This one, do you have any repeating inputs? No. So that's all you care about. Last one, do you have any repeating inputs?
Yes.
Do they give you different things? Yes. So that's not a function. Do you agree? If I have a function machine, only one number should come out.
Yes.
That's called a function. Okay, one number goes in, and another number comes out. If I put a number in, and 2 different numbers come out, that's not a function. So that last one was not a function. So we do need to see more examples than this just to come up. There's one example that's not really shown here. For example, let me write one here on the side, and please add this one as well. This is going to be a little bit easier. What if they're written in order? 1, 2, 3, 4. Is this a function already for the x's? Yes, this is a function because we don't have any repeat buttons. We don't have any repeat inputs. So it doesn't matter. This could be 1 can give me 1, 1 can give me 2, 3 can give me 3, and 4 can give me 5, and that's still a function. Because the buttons are unique. 1 gives me Coke, 2 gives me Twix, 3 gives me apple juice, and 4 gives me waffles. And that's okay. It's a function. Each of these inputs are unique. There's another example that's really good. Check this one out. One, 2, 3, 4. 1 gives me 1, 2 gives me 2, 3 gives me 3, and 4 gives me 3. Is this a function? What do you think? Check this out. 1 gives me 1, Coke. 2 gives me 2, Pepsi. 3 gives me 3, apple juice. 4 gives me 3, also apple juice. Is this okay? Is it okay for 2 buttons to give me the same thing? I'll write that down. Is it okay for 2 inputs, X buttons, to give me the same output, which is y or f of x? The answer is a resounding yes. So this right here is a function. That means every button's gonna give you something. One more example. The trick is, do you see any repeating inputs? 1, 2, 2, 3. What do you think about this one? Is this a function? Maybe. Watch this. 1 gives me 50. 2 gives me 9. 2 gives me 13. And 3 gives me 7. Is this a function? All we have to do is look at our inputs. Do we have any repeats? Yeah, that is an issue. 2 gave me 9, but the button 2 also gave me 13. That's like saying 2 gives me orange juice, but the same button number 2, the input, gives me orange soda. So 2 gives me orange juice, 2 also gives me orange soda. A function machine, you want the button to have a unique output. So this one is not a function. The button number 2 gives me 2 different outputs. That is not okay. So to be, write this down, to be a function, it's kind of confusing at first, but as long as you're understanding, if this was a vending machine, would it be okay to have 2 different outputs? To be a function, every input x must have a unique output y. So 2 giving me 11 and 2 also giving me 15. That's not okay. That's not a function. 2 giving me 5 and 2 also giving me 5. That's okay. That's okay. Because it's just a repeat of the same thing. So it says here, a relationship between inputs and outputs is called a function if the inputs and outputs behave like a soda machine that is functioning properly. It says to discuss with your team what it means for a relationship between inputs and outputs to be a function. We already wrote that down here. To be a function, every input, I think I had a glitch there, let's see. To be a function, every input has to have a unique output. Next question, examine each of the graphs and the table below. Compare the inputs and outputs and decide if the relationship could be a function. Explain your reasoning. So for this one right here, x is our inputs, y is our outputs. Do we have any repeating x's? We have -3, we have -2, we have -1, we have 1, 2, and 3. Those are our x's. This is going to be a function. There's no repeating inputs or x's. Next question. Take a look at this one. This one's not a function. Do we have any repeating inputs? Check this out. Take a look at the number -1 right there. We have -1 comma 0. We also have -1 comma about 2. We also have -1 comma about -3. This is not a function because -2, for example, has multiple outputs. You know, there's an easy way to do graphs. Is does it pass something called the vertical line test? Does a vertical line go through multiple points? If it goes through multiple points, it's not a function. For example, at 1, x is 1 right here, we have an output over here at about 2. We have an output at around negative 1.5. And we also have another output at around negative 3. Since this input is giving us multiple outputs, that's not a function. It's like pressing this button and it gives you different things. Okay, next one, the tables. Negative 8 gives us 11. 4 gives us 3. 11 gives us negative 8. 6 gives us 3. And negative 8 gives us 11. So let's use the trick. Do we have any repeating inputs? Where are they? Yeah, negative 8. Negative 8 repeats. This is a good one, though. Negative 8 gives us 11. And negative 8 gives us 11. Is this okay? Yes. This is a function. It's just repeated, and that's okay. Last problem here. Let's try the vertical line test. If I draw a vertical line, does it only go through one point? Right? Anywhere I draw this vertical line, it's only going to go through one point. So this is a function. Every input has exactly one output. So therefore, it's a function. Okay, let's flip over to the next page. Problem number 45. Jade noticed that the line graphed at right is a function. Why? Because it passes the vertical line test, right? If there's only one dot on that line, not two, but only one, then it's a function. So Jade says, I think that all lines are a function. First of all, is this a function right there? Does it only go through one point? Yes. You can say this is a function. But Jade is saying something extreme. Jade says, hey, I think all lines are functions. Is that true? So think about it. Are all lines functions? Let's see. Is this a function? Yep. The line goes through only one dot. Is this a function? Yes, because it goes through only one dot. So I'll say yes. I'll say yes. What about if it's negative? Is that a function? Let's draw the vertical line test. VLT. Vertical line test. Write that down. VLT, vertical line test. When I draw a vertical line, does it only go through one point? Yes. There's only one line that doesn't go through exactly one point. What if I draw a vertical line? Is this line a function? Take a look. When I draw the vertical line test going through it, how many dots does it go through? It's going to go through this dot. This input's going to give me this output. This input is also going to give me this output. So this is the only example where a line is not a function. So to answer this question, is she correct? No. The diagram that we need to support it with is a vertical line. A vertical line doesn't pass the vertical line test. So for this last part of the lesson, I want you to write your learning log. In this space that's right here, I want you to explain a little bit about what we learned in today's lesson. It says, throughout this course, you are asked to reflect on your understanding of mathematical concepts in a learning log. Writing about your understanding will help you consolidate ideas. Is there something you found easy to understand from this lesson? Was it the vending machines, perhaps? Was it the vertical line test? Was it the graphs? Was it the tables? Is there something that you felt was easy? Was there something that you felt was hard or you didn't understand yet? All that is normal in math. Writing about your understanding will help you consolidate ideas, develop new ways to describe mathematical ideas, and recognize gaps in your understanding. It's important to write each entry of the learning log in your own words so that later you can use your learning log as a resource to refresh your memory. In this learning log entry, in this space right here, describe what it means for a relationship to be a function. Maybe you want to talk about the vending machine with the buttons. Is it a function if I press multiple buttons and it gives me the same thing? Is it a function if I press a button and it gives me different things? Write about what it means to be a function. Think of a type of machine that you use on a regular basis and describe how it also operates as a function. Title this entry Functions and include today's date. So you can go ahead and say functions, and you want to write today's date. And in this space, since I give you the space, so you don't need to write it in your notebooks, just write your reflection right here. I'll give you some time to do that. All right, that wraps up today's lesson on section 1.2.2.